3. Okay, and then chapter 4, then finish. Okay. So basically, in your chapter 3, you will deal on introduction, advantage of digital transmission. Okay, last time in your AM and FM cover analog. Okay, analog. Okay, right now in chapter 3, we deal with digital signal. Clear? Okay, and then you will learn on pulse amplitude modulation, pulse, pulse width modulation, and pulse position modulation. Okay, and then the third one, PCM, pulse code modulation. And then you will deal with the amplitude shift keying, frequency shift keying, phase shift keying. Okay, data communication modems. Okay, and then multiplexing. Okay, TDM, FDM. Okay, TDM time division multiplexing, FDM frequency division multiplexing, and so on. Okay, before we start, okay, so want to give you an overview. Okay, for example, advantage of digital transmission. Okay, remember analog signal. Okay, analog. Okay, analog signal. Normally they form in sinusoidal form. Okay, analog signal. Digital. Digital. 0, 1, 0, 1, 0, 1, 0, 1. Clear? Okay. So basically, and then we go to, it's okay lah. After this, we go one by one. Okay, introduction to digital transmission. Okay. Digital transmission enable network to support many service. Okay. TV also got digital. Okay. And then your smartphone using the digital technique. Okay. Okay, the advantages. Okay. When you deal with the digital transmission means 0, 1, 0, 1, 0, 1, 0, 1. First is the noise immunity. Okay. And then easy storage and processing, easy to measure. For example, okay, easy to measure. Measure why? For example, here, for example, if you refer to here, the digital signal, you should know something. Let's see the error occurs at bit 1. So you know already, oh, at the bit 1, this is the error. Okay, how about error at bit 0? The bit 0, you know the exact location, 1 or 0. If you are using analog, okay, for example, you are using analog, sometimes you don't know where's the location. For example, is it here, point A, point B, point C, point D, not very firm in terms of, let's say you represent in terms of voltage, right? Voltage, not very firm. You don't know this location, not very firm. The value here, okay, not, you don't know. Is it 3.4 volt or 3.3 volt, for example? Okay, for digital, very easy. Okay, firm at bit 1 or bit 0. Okay, and then error correction and detection can be utilized very easy at bit 1 or bit 0. Okay, disadvantage, require bigger bandwidth. This is the bad thing. Okay, requires bigger bandwidth. Okay, analog signal need to be changed to digital first. This is the thing. If you are using analog, your system is digital, not working. Must be changed. Change using what? Using analog to digital converter, ADC, or DAC, digital to analog converter. Wait, some of your friend. Okay, so let's proceed. Okay, now additional encoding. This one A to D lah. This one ADC, or sometimes we call A analog to digital converter. This one DAC, secretary. Okay. Okay, and then need precise time synchronization between the clock. This one should already record or not? Wait for a while. Okay. So record already. Okay. Need precise time synchronization between the clock and transmitter and receiver. Okay. When you do this, they got the timing. Okay. Okay. Time must be need the precise time. You cannot play around time. Let's say 1 second for bit what? Bit 1. Okay, and another 1 second for bit 0. Must be precise time. You cannot say something like this one at the 1 second, the 1 second become 101. No, sometimes you, let's say that bit is 1 at the once. Okay, after this I show you lah. Okay, right now if in theory very difficult to explain. Okay, now this is the digital communication block diagram. Analog source, sinusoidal, analog to digital ADA. This one also we call ADC, analog to digital converter. Okay, what happened here means in this process, analog to digital converter requires 3 process after this. Okay, and A to D, okay, ADC lah. Okay, ADC very simple. They got 3 process. The first one is sampling, quantization. Okay, sampling, quantize, and then encoder. This one got encoder. Wait. Sampling, quantization, encoding. Okay. Encoding. Okay. This one, A to D, means you got the sinusoidal signal. After you do analog to digital converter, the signal become bit 0, 1, 0, 1, 0, 1. Okay, 0, 0, 1, 0, 1, 0, 1, something like that. Bit streaming. Okay, now this process, analog to digital converter, normally we for your final exam and so on, we cover on PCM. PCM is the pulse code modulation. Pulse code modulation. Okay. Okay. And then we'll go to source encoder, channel encoder, modulator, power amplifier, channel, low noise amplifier, demodulator. Okay, this one modulator, inverse process demodulator. To get back the, let's say you send the analog signal. Okay, at the end, we got the analog user and also digital user. This is the best thing when you are using digital communication system. You can send the analog source at the same time. You can also get the you can go to digital user. It's okay. After this, you will understand. Okay. Wow. DAC. This one DAC. DAC means from digital you convert back to analog. Okay. This one, as what I mentioned before in the previous slide, PCM. See, PCM, this is a process, process of sampling, quantization, and also encoding. Okay, so as what I mentioned before, this is on the DAC, ADC here. The process occurs at ADC, analog to digital converter. ADC, okay, means from analog signal, finally you got the streaming of bit data 010101. Okay, so we got the sampling. What is the sampling? Sampling something like when you got the analog signal, you sample. You put something like you chop the signal. Okay, you chop the signal, and then how about the quantizing something like the assign the level. Okay, assign level, quantizing something like assign level of signal, and then encoding 010101. Okay. Okay, we go to the pulse modulation. Okay, what is the pulse modulation? Process of changing the binary pulse signal to present the information to be transmitted. Okay, binary pulse. What is the binary pulse? 010101. Okay. 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 Actually, there are four basic form of pulse modulation. You got amplitude, width, position, and pulse code modulation. Okay. Basically, in your final exam, we cover this thing. Favorite question. Okay. Okay. Now, let's look the difference between palm, pulse width modulation, and pulse position. This one, amplitude, width, and then position. Okay. Now, let's look the difference between amplitude, width, and position. Okay, let's see. Amplitude means you play with amplitude. Okay, you play with amplitude. Okay. How about the width? Width you play in terms of width. Okay. You can see something like at the most top positive cycle, you can see something like this one become bigger, okay. Width become increase. This one the most um, large value in terms of width. Then how about the most top negative cycle? The most top negative cycle. Negative cycle you can see become thin. Okay. See the difference between the most positive cycle, top positive cycle, and also top negative cycle. You can see the difference. Okay. Pulse width modulation. Okay. Some of the students will say, sir, what's the what in pulse width modulation? Where I can see it? Okay. Pulse width modulation normally you can see on your light dimmer. You know light dimmer? Lampu bagi cerah dengan gelap tu. To bulb you. Kan ada dimmer kan? Rumah orang kaya dia kalau macam kita, kalau macam rumah orang yang biasa saja, you on, switch off the lamp. Tapi kalau setengah tu yang kaya sikit tu dia ada dimmer. For example, chandelier you right, you want nak become brighter or nak bagi dia kurang, bagi dia gelap. Okay, that one we use PWM. Nanti tengoklah machine also, nanti you guna in factory, kita akan guna PWM and PPM. Normally you boleh tengok nanti. Okay, now let's look on the position. Okay, pulse widths are the same. Okay, width same. In this case, all the width same. Okay, but their location change. This is the thing that interesting thing. Okay, means for the see let's say we make this sequence. For example, this one. This is the sequence. Okay, this is the sequence. Okay, make this the sequence. Okay. Okay. You can see this dotted is the original line. This dotted is the original line. Suppose extract from this sinusoidal form. You see something like actually this one move to the left, move to the right. Okay. And just think about that on the first class. Okay. Next class I'll give you tutorial and so on, and you can see something like Servotel in the detail. Now right now just focus something like move to the left, move to the right. Okay. Okay, pulse position. Now we go to the characteristic of the pulse amplitude modulation. Okay, the amplitude of each pulse sample is proportional to the amplitude of the message. Okay, at the time of sample. If you don't understand this thing, you can go back here lah. PM, you can see back. Okay, from this figure. Sometimes students don't understand, right? This explanation. Go back to here. Okay, so you become understand what happened. Okay. Okay, this is the the simplest and least expensive to implement. Okay, actually, when you deal with this technique, PAM, PWM, PPM, actually PAM is the simplest technique. Okay, actually, all of these things need as something that we play with electronic circuit. Okay, electronic circuit. For example, you got the resistor, the arrangement of the resistor. So PAM is the simplest form. Okay. very similar to amplitude modulation. Okay. Now we go to the PWM. Okay, this technique varying the width, okay, width, but the constant amplitude. Okay, constant amplitude. You see here, constant amplitude. Okay, constant amplitude. Okay. And then how about the pulse position modulation? Okay. PPM is the when the position of the constant width and the constant amplitude pulse within prescribed time slot is varied according to the amplitude of the modulating signal. You don't understand, right? We go back here, you see something like very simple. Okay, you see something like when the top positive cycle it become move to the left. Okay, okay, from the origin sampling, and then for the top negative cycle here, you can see something like the signal move to the right. Okay, it's okay lah. After this, when I give you example, then you will understand. Okay. Now we go to the PCM. This one very important. Okay. PCM. What is the PCM? Okay, PCM as I recap again, in the analog to digital converter means convert from analog to digital. Analog to digital. Okay. Okay. The first okay, remember from here is the analog signal is sample. Sample means what? You sample. This is what we call sample. Okay, sample normally we are using Nyquist rate. Okay, Nyquist rate. What is the Nyquist rate? Fs, okay, bigger or same to Fm, information signal. Information signal. Okay. After you get this thing, the sample signal is quantized to binary bit stream. Okay. Quantize something like this. We assign a level. Okay. Level of the signal. Level. And then the quantized value are encoded as a stream of bit. Means at the after this, at the encoding, something like what happened become 010101. Okay, bit streaming. Don't worry. After this, I show to you. You will happy. You will easy to get. Okay, you confirm you understand. Okay, now this is about process. Okay, sampling, quantization, coding. Okay, normally sometimes in the test and so on, final exam will say, okay, tell me something like what is the three process involving in pulse code modulation. Normally you must remember this thing: sampling, quantization, and coding. Okay, okay. Okay, sampling. This is sampling, Okay, sampling we got three things. Ideal sampling, natural sampling, and also flat top sampling. Okay, what is it different? Okay, ideal sampling something like ideal. Okay, ideal sampling. Okay, you see something like you do like this straight line, this thing. This one ideal sampling. Okay. How about the natural sampling? And natural sampling like this. This is what we call natural sampling. Okay. Normally, we are doing ideal sampling for your final exam and test. We are using ideal sampling. Okay, but show you there's another form. Okay, natural sampling. Okay, flat top means you take at this point, you make something like this. This one time, something like this. You take at this point and then you make in terms of the time, desired time you assign. Okay. Okay, now sampling theorem. This is important. As what I mentioned before, this thing you must know this formula. Okay, this formula you must know. Copy out. Okay, Fs equals to 2 times Fm. This one, what is the Fm? Something like information signal. After this, you will know information signal. Okay. Okay. Sampling. Okay. So this is something like what happened? Fs equals to 2F. Okay. means Nyquist sampling rate. This one oversampling. Fs for F. Okay. This one Fs equals to F. Okay. But normally settling something, the best thing is that we are using Nyquist sampling rate. Okay. Okay. You can read by yourself lah. Here, Nyquist rate Fs equals to 2Fs, create a good approximation of the original sine wave. This one, create the same approximation, okay, like this, but this is redundant and unnecessary, okay? So, redundant and unnecessary, okay? So, the third one is does not produce a signal that look like the original sine wave. This one not complete, okay, not complete. Positive cycle and negative cycle not complete. This one something like you create wastage here. This one not complete in term of original. Okay, this one good, just nice. Okay. Okay. I think this one only quantization. Okay, ni this one quantization is the process converting. Okay. This something like the infinite number of the possible to infinite number of condition around the amplitude of the flat top sample and manageable number of the level. You don't understand, right? Okay, don't worry. So give you simple thing. Assign the value. Okay, now so telling you something. Here right now you can do something like, okay, so telling something. You can do something like 2 bit, 3 bit, 4 bit, 5 bit. Okay, now you become confused. So, why is that? Okay, remember something, certain something. 2 bit and 3 bit, 4 bit and 5 bit will give you something like in terms of the magnitude. Okay, this one, how many bit we are using? 1110 01 00 00 00 01 1011. This one how many bit? Last time you study about this thing, right? 2 power of n. Okay, 2 power of n, let's say you are using 2 bit. This one is telling you something. This one you learn on in digital subject. Okay, 2 power of n, let's say 4, right? Last time you learn about, let's say 2 power of n, you got 4. For what? Actually, you got 4 level. Okay. Okay, let's say you are using this one bit. Sir, I don't understand, sir. What is the bit? Actually, this one lah. 0, 0. This one, for example, 0, 0, 1, for example. 4 bit, 0, 1, 0, 1, for example. 5 bit, 0, 1, 0, 1. Something. This one, 2 bit. 1, 2. This one, 1, 2, 3. This one, 1, 2, 3, 4. But last time when you you create the truth table. Betul tak? Betul tak? Before this, you bila dapat 2 bit, you buat truth table. Truth table kalau 2 bit apa? You akan dapat apa? 2 power of n, you akan dapat 4 level. Lepas tu you buat macam ni truth table. 0, 0, 0, 1, 1, 0, 1, 1. Betul tak? Last time you buat macam ni. Lepas tu you buatlah truth table dia apa? Sebenarnya itu sebagai tahu you. Sebenarnya when you do 2 bit, you assign 4 level. Ni level dia, level 1, 2, 3, 4. Kalau yang ni actually 3 bit, 3 bit kan? Ni sebagai tahu something, yang ini adalah 3 bit. Okay, dia ada sign. Ini sebenarnya adalah 3 bit. Okay. Okay. Tak apa, you nanti after this you akan faham. When I give you example, easily you will understand. But remember, dulu you belajar macam AND gate ke, NOR gate ke apa semua kan, you hanya terus dapatkan assign the value. Sekarang ni, in this subject, we assign the voltage. Ni yang saya nak bagi tahu. For this subject, communication, you learn, this is new thing. Last time you belajar pasal 0, 0, 1, 0, 0, 0, 0, 0, 1, 1, 1 and so on and so on. But right now, we assign in terms of something like voltage. Okay, don't worry. After this, if you see here, you don't understand, but if I give you an example, exactly tutorial, exactly you understand perfectly. Okay. Okay, we go to, okay, this is the new thing. Quantization level. L equals to 2n. As what I mentioned before, we want to assign the level. Okay, let's say this one, this is example, right? Let's say this one. This one 2 bit or 3 bit? This is example. 2 bit or 3 bit? Hmm.
3 bit, sir.
3-bit, eh? Okay, very good. So remember, this is the new formula you must remember. L equals to 2 power of n. Okay, remember? So 2 power of n, let's say bit n equals to 2. So level equals to L equals to 2 power of 2 equals to 4 level. Okay, let's say n equals to 3. L equals to 2 power of 3 equals to 8 level. 8 level 0, 0. For example here, 0, 0, 0 to 1, 1, 1. For level means 0, 0 to 1, 1. Okay. This one digital lah. I think you forget, but so can give you refreshment after this. Okay. Now we go to the next formula. Okay, delta V. Okay, delta V. Okay, delta V equals to V max minus V min divided by L. Okay. Now L extract from where? From the previous slide. Okay. Level. Okay, quantization level. So from here, Vmax minus Vmin. Okay, what is the Vmax? Vmax is the value here. Vmax. Where's the Vmin? Vmin is here, the most lower part. Okay. 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 Here's something like you assign the value. The every bit. Let's say you are using 3-bit. 3-bit can assign here. Okay. Right now you just see the arrangement of something like where's the location of the Vmax, where's the location of the arrangement of the bit, okay, and so on. Okay, after that I show you how to get this thing. Okay. Okay, delta V, Vmax minus Vmin over L. Okay, the next formula you must understand, quantization error, QE plus minus delta V actually. Delta V, this one delta V. Okay, QE equals to plus minus delta V over 2. Okay, quantization noise. Okay, SNRDB 6.02 NB plus 1.76 dB. Okay, now dynamic range. Dynamic range, okay. So this is the formula for dynamic range. dr equals to Vmax over Vmin equals to Vmax over delta. Okay, and then dr dB 20 log because we deal with voltage. You got this formula. Don't worry, I give you a tutorial, then you know how to use. Right now I don't have the value so that you become headache. Don't worry. Just copy out the formula. Okay, dynamic range. Okay, then we go to encoding. Encoding. Okay, this is encoding. Okay, know this formula. N equals to log 2 L. Okay, L equals to N over 2 power of N. What is the L? L, level of quantization. It's okay lah, this one keep repeating the same thing, but adding encoding something like 010101 bit streaming. Okay, now encoding, actually you already know, but something like new things for you, but actually very simple. Okay, 000, how about the pulse waveform? Something like straight line. 001, 001, actually this one 010 here, 011 here, 100, 101, 110, 111. That's all. Okay, pulse waveform. This one binary number, right? In the pulse waveform like this. Okay. Okay, quantized level is something like the level lah. Okay. This one in this case we are using 3-bit. 3-bit, so 2 power of N. 2 power of 3. You got 8. That's why you got 1 to 8 because you got 8 level. Okay. Understand or not? L equals to 2n. Okay, I recap again. This one 3 bit, right? So 2 power of 3 equals to, you got 8 level. But sometimes in digital, you start from 0. Sometimes 0 to 7. Here 1 to 8, right? Sometimes start 0 to 7. Okay, depend on the question. After this, I give you the question. Okay, now, encoding. Okay, this one I think better skip for a while so that you don't confuse. Oh, wait. Quantize number 1. Pump value 1.1. It's okay lah. I later on. I worried you don't understand. Okay, bit rate and bandwidth. We go to the bit rate. Okay, this is a new formula you must know. Bit rate equals to, bit rate is the rate of change of digital information signal during 1 second. Okay, NB time Fs. Okay, you must know this formula. And then minimum bandwidth. To pass a digitized PCM signal, bandwidth equals to NB time Fs. Okay. Actually same, you see. NB Fs here also same. Okay. Okay. PCM decoder. Same thing. PCM transmission system. Okay. Example 1. I think I give you another example. Okay. Closely. Suggest a sampling rate. Okay, PCM, this example I give you next class. Okay, now we go to the line coding. Okay, so telling you something. What is the line coding? Okay, line coding consists of representing the data signal to be transmitted by amplitude and time discrete signal. Okay, something like this. Okay, last time you got the digital data, right? Digital data, this one from PCM. Okay. Now, what is the line coding? Line coding, something that when you send to the encoder, okay. So, want to tell you something. Each line coding give you in the different application. For example, so tell you something. Line coding. Okay. This one PCM, right? Okay, line coder and then channel. Okay. Remember something. For local area network, for example, for local area network. Local area network. Okay. For local area network, normally we are using line coding, something like Manchester coding. Manchester coding. Okay. Different line coding, different application. Okay. So what is the purpose of the line coding? Synchronization, error detection, and error correction. This is the purpose of line coding. Okay. So how the line coding look like? Okay. Okay, line coding look like this. Okay. Okay. Line coding look like this. This one from PCM, right? PCM, and then we fit into something like up to you. Okay. Here, before this is a PCM output. PCM output. Okay. After you got the PCM output, 0, 1, 0, 1, 0, 1, 0, 1, and so on. You fit into the line coding. Okay. Line coding, we have 3 types. Unipolar. Okay, remember this thing. Polar and bipolar. We got 3 types. Okay, unipolar, polar, and bipolar. Okay, this one you normally heard sometimes bipolar disorder. Okay, bipolar. Okay, ada orang sakit bipolar and so on. Okay. Okay, now ni saya bagi tahu something. Okay, line coding unipolar. Okay, now we go to the unipolar. How to know that one unipolar or polar? Okay, unipolar, okay, only one voltage level. Okay, kenapa saya cakap macam tu? See why only one voltage level, nampak tak? Positive cycle only, nampak tak? Dia ada positif je, negatif tak ada. Negatif don't have. Faham tak? Faham tak? Kalau unipolar. Kena ingat nanti you kena, okay, in your quiz, so give you this example, for example from PCM output, right? Okay, draw the signal for unipolar, okay, bipolar and so on. Okay, how it look like after this? Macam ni kalau quiz. Quiz nanti it will come like this. Okay. Ya, saya tunjuk Silakan normally. Right? Okay. Normally dalam quiz we're asking you like this. Wait something like this. Okay. Okay. Given that draw the line codes for 10, 10, 11, 001. You must draw. For example here, right? You must know how the signal look like. Okay. You must know how to draw. For example, unipolar. Unipolar only got positive. Cycle, what happened? 1 for here, 1, 0, 1, 0 here, 1, 1, 1 here, 0, 0. The next one something like that. Okay, so can change it. Okay. Now let's look how to draw. Okay, activity how to draw. That's why you must know the concept of unipolar, bipolar and so on. Okay, now go back here. Okay. Okay, so this is the keyword. Unipolar, polar and bipolar. Unipolar means what? Only one level only. Okay. One voltage level only, positive cycle only. Okay, nampak tak? So, understand or not? Ini unipolar from this figure. Faham ke tak? Kalau tak faham, saya akan bagi you take time untuk understand this signal, how to draw. Okay, understand or not? This one unipolar. Faham ke tak?
Faham sir.
Faham kan? Unipolar maksud apa? Ada satu level saja, one level only. Clear? Okay. Dalam unipolar, we got also NRZ. What is the NRZ? Ni. Okay. NRZ is the non-return zero. Okay. Positive voltage represent binary 1. Zero voltage indicate binary 0. It's the simplest line code. Okay. Now, kita pergi pada unipolar. Okay, tadi ni unipolar kan? Okay, unipolar. Okay, ini non-return zero. Okay, non-return zero. Okay, now non-return zero I. Okay, is the signal is inverted if 1 is encountered. Yang ni lain sikit tau. Yang ini tadi non-return zero. Okay, sebab tu saya kata kena understand the term. This one non-return zero. Unipolar non-return zero. This one unipolar, the same unipolar tapi dia ada I. Okay, I. Okay, tengok sini ada I. Kalau ada I, what happen? Inverted if 1 is encountered. Maksud dia kalau 0, bit 0, right? 0, no change. Okay, the first one tak ada masalah. Okay, but when you meet, contoh 1 bertemu dengan 1, dia akan change. Faham tak? And then 1 bertemu dengan 1, dia akan change. Okay, 0 for follow. Okay, follow. Okay, and then ni kenapa jadi macam ni? Saya pun dah pening. Okay, this one unipolar. Wait. Sekejap macam nak hilangkan dia. Okay, now in non-return zero unipolar, the signal is inverted if 1 is encountered. Maksudnya dalam kes ni, kosong-kosong tak ada masalah. Bit 1, you put 1. When you meet 1, dia ubah. You jumpa lagi, meet 1 dia ubah. 0, dia ubah. 1 sepatutnya, okay, 1 dia ubah. Okay, ni semua ubah Kosong dia follow. Follow. 1 dia ubah. Understand or not? Okay, tengok dia sekejap. Sebagi masa dulu. Faham tak maksud dia? Okay, kalau tak faham, saya cerita lagi sekali Okay, dia kena ambil tau, ini logical thinking tau. Kalau you tak dapat fikir secara logical thinking, you akan pening. Okay, macam okay, now listen macam mana cara faham. Okay, saya padam balik so that you faham lagi sekali. Semula confused juga, tapi sekarang saya dah faham dah. Okay. Okay, satu if bit 0 no problem. Bila you ada bit 1 tak ada masalah. Ini mula-mula you lukis saja macam biasa. Okay. Lukis macam biasa. Bit 0, 0 lah. Bit 1, 1. Okay. Bila jumpa 1, dia akan ubah. Change Dia akan change. Bila dijumpa lagi 1 sini, dia akan change. Bila ada kosong sini, dia akan follow. Follow previous signal. Bila jumpa 1, dia akan change. Maksudnya setiap bit 1 yang jumpa, dia akan berubah. Betul ke tak? Understand or not? 0 akan follow. Nampak tak? Sebab tu sini, kenapa 0 sini atas? Sebab dia follow. Kalau jumpa je bit 1, dia akan berubah. Understand or not? When you find bit 1, it will change. Okay, that's all. Think about that. Boleh ke tak? Faham ke tak? Okay, faham tak ni? Non-return 0i.
Faham sir, faham.
Faham kan? Maksudnya sebab tahu nanti kan quiz akan keluar tau soalan ni. Nanti you tak faham nanti. Okay, simple Kalau jumpa bit 1, dia change. Dia akan berubah. Kalau kosong, selepas bit 1 tu dia akan follow. Kalau dia berjumpa je bit 1, dia akan change. Clear? Boleh? Okay. Now let's go to the polar. Tadi unipolar. Ini polar. Polar pula. Okay. Ini penting tau. Kalau you terlupa tak erti buat ni, saya pun tak dapat tolong you. Okay. Dalam polar. Okay. Dalam polar. Okay, polar, we got non-return 0, return 0, Manchester and also differential Manchester. Dia ada bawah polar, ada non-return 0 juga. Ada this one non-return 0 non-return 0, return 0. Okay, Manchester, differential Manchester. Now, tadi unipolar. Polar, you got 2 voltage level. Dia ada positif dengan negatif. Okay, jom slow-slow we go. Okay, return 0. Okay, tengok student sir, tengok ni. Return 0. Okay, this one return 0. Okay, return 0. Okay, so bagi tahu something Return 0. Okay. Dalam return 0, okay, dia ada nampak ni, every bit dia ada 2. Betul tak? Juga ada 2 signal sini. Nampak tak? Dia ada 2. Kalau non-return 0, dia ada 1 saja. Nampak? Non-return 0 dia 1 saja. Dia tak ada, understand or not? This one non-return 0, return 0 ada 2. Nampak tak? Ada 2, dia macam tangga. Setiap bit ni dia ada 2. Faham ke tak? Dia ada 2. Maksudnya okey, tak apa. Naik tangga atau turun tangga, tak apa. Now, saya bagi tahu how to draw this thing. Okay, how to draw this thing. Okay, return 0. Okay, saya bagi tahu actually kita ada satu every bit kita ada naik tangga Okay. Ataupun you turun tangga setiap bit. Kalau macam non-return zero, dia ada satu saja. Macam ni. Okay. Tapi kalau return zero, kita ada dua. Satu, dua. Sini ada satu saja. Okay. Satu saja, satu, satu. Sini ada satu, dua. Okay. Now, very simple. Sebagai tahu something. Kalau zero, naik tangga. Okay. Lokasi dia sama. Okay. Naik tangga. Okay. Naik tangga. Okay. Naik tangga. Okay. Kalau one, turun tangga. Tengok ni. One, turun tangga. One, turun tangga. Turun tangga, turun tangga. This is cara you nak hafal. Saya tak boleh nak tunjuk lagi yang lain. Okay. Understand or not? Kalau tak faham, saya akan stop. Saya akan bagi you faham dulu. Okay, bit 0 macam ni. Di sini bit 0, bit 1 macam ni. Itu je yang saya boleh help. Faham ke tak cara nak lukis? In between dia tu you sambungkan. In between you kena sambungkan. Okay. Okay. Ayah masa dulu yang ni memang pening. Actually tak pening pun. It's something like method of drawing. Okay. Okay. Faham ke tak? Dah faham? Saya nak go to the next slide. Okay, faham tak? Turn on your microphone. Saya tak dengar.
Faham sir, faham sir.
Faham? Very good. Okay. Now we go to non-return zero encoding. Okay. Non-return zero. Tadi unipolar also got, polar also got non-return zero. Non-return zero maksudnya dia ada satu saja. Okay. Satu saja, dia tak split into two. Tak ada taik tangga, turun tangga, tak ada. Okay. Now, non-return zero, polar, macam mana? Okay, tadi unipolar. Last time you learn about unipolar. Okay, unipolar, one level voltage only. Voltage. Okay, bipolar. Bipolar you got two level voltage. Okay, so satu, kalau kosong dia dekat negative side. Okay, ni beza dia very simple. For bipolar, satu dekat positif, zero at negatif. Itu je teknik dia. Understand or not? Okay. Yang ini unipolar, sorry sekejap, saya pun dah pening ni. Polar, wait unipolar, polar, bukan bipolar this one. Oh my god, pening. Saya pun ajar kena pening benda ni. Okay, ini polar ni. OMG. Polar, two level voltage. Sorry polar non-return zero. Okay, so clear? So go to the next slide. Okay, remember unipolar, non-return zero. Saya telling something, non-return zero. Okay. Okay. Non-return zero means dia tak ada bagi dua. Tak ada naik tangga, turun tangga. Okay. Kalau return zero, dia ada naik tangga, turun tangga macam ni. Okay. Dia ada split. Yang ini tak ada. Okay. Okay, so okay lah, nanti you faham lah. After you see some ni, you will understand. Don't worry lah, ini paling simple. Okay. Now, we go to the polar. Tadi unipolar, right? Polar also got non-return zero I. Okay. Non-return zero I. Unipolar also got. Polar also got. Okay. Non-return zero I. The signal is inverted if a 1 is encountered. Maksud dia macam mana? Okay. Satu bertemu satu, ubah. Kosong follow. Bila jumpa satu balik, dia ubah. Bila jumpa satu balik, dia ubah. Jumpa satu, dia ubah. Kosong, dia follow. Itu je saya boleh bagi tahu. Okay, faham ke tak? pola null return 0i. Okay. Satu. Okay, lepas tu berjumpa satu, meet one dia ubah. Bila follow zero, zero ni dia akan follow. Dia akan follow. Bila jumpa satu balik, bit satu dia akan change. Okay, dia akan change. Jumpa lagi satu dia akan change. Jumpa bit one dia akan change. Zero dia akan follow. Okay, understand? Okay. Now saya nak move dekat slide lain ni. If you understand, so we'll go to the next slide. Okay, your lab one your lab one, forget to tell you. Okay, your lab one, two members, two member, one report. Okay, when to submit? Next week. Next week, hari, this one is Tuesday. Thursday, so we'll give you link, link for submission in Kalam. Don't worry, I will give you the link. Okay, everyone understand? Lab 1, lab hari tu yang you buat tu, satu report, dua member. Okay, satu report saja hantar kat sir every 2 member. Okay, submit bila? Next week Thursday. Okay, submit, nanti saya bagi link dalam Kalam, you follow. Nanti saya bagi sekali rubrik. Okay, clear tak?
Clear sir.
Okay, very good. Now kita pergi sini. Ni tak payah tengok, nanti pening. We go to Manchester. Manchester ni famous. Selalunya guna dekat LAN, Local Area Network. Yang kamu guna kat kampus kamu tu, when you dekat you punya campus, yang you transfer data semua tu, kita guna Manchester encoding. Sebab tu kena belajar. Okay, very simple. Okay, zero like this, turun tangga. One, naik tangga. Itu je saya dapat ajar. Lain saya tak boleh nak ajar, nanti kamu pening. Zero, turun tangga. One, naik tangga. Faham ke tak? Itu saja. Clear tak? Remember, kalau ada positive cycle, negative cycle, this one we call polar. Okay, ada dua level voltage. Okay, faham? Okay. Dah faham Manchester encoding? We go to Manchester encoding. Okay. Satu lagi, we got differential Manchester encoding. Tadi Manchester encoding, this one we call differential Manchester encoding. Okay. Macam mana cara nak lukis dia? How to draw? Okay. One mapped into no transition, zero mapped into transition signal level. Okay, maksud dia apa? Okay. Cuba tengok apa different dia. Okay, so telling you something, masa nak lukis, remember, dia punya starting follow Manchester punya. Okay, maksudnya zero naik tangga, okay, one turun tangga. Okay, okay, now zero macam nak cakap, zero dia akan follow. Kalau satu, sekejap, Silap ke apa ni? Sekejap. Kadang-kadang silap juga ni. Differential. Oh silap. This one Manchester. Manchester turun tangga. Sorry sesilap tadi. Silap this one silap ni. Wait. Kita tengok kat sini lah dulu. Okay. Different between Manchester and differential Manchester. Cuba tengok dulu. Okay. Ni kalau Manchester, 0 turun tangga, 1 naik tangga. Okay. Cuba tengok apa beza differential. One. Okay, apa yang nampak kalau differential Manchester? Cuba tengok apa beza. Ni tengok gambar. Okay, cuba bagi tahu. Okay, no inversion Okay, mula-mula tengok yang ni. No inversion. Next bit is 1. Inversion. Next bit is 0. Okay, mula-mula tengok macam mana cara dilukis. Okay, mula-mula 0. Okay, and then 1 jadi apa? 1 dia macam ni. Okay, kalau you jumpa lagi 0, 0 dia akan follow. This one follow. Okay. The next bit dia jadi follow. Okay. Bila you jumpa 1, dia akan change. Bila jumpa 1, dia akan change. Okay. Okay. Faham ke tak ni? Okay, some of the student pening kan? Okay, sebenarnya tak ada masalah. Okay, sebab tu saya bagi tahu, sometimes Manchester, for differential Manchester, you boleh start kosong macam ni pun boleh. Okay, tapi you mesti follow rules. Bila ada satu, dia akan change. Bila bertemu dengan bit 1, dia akan change. Bila bit 0, dia akan follow. Okay? Understand or not? Tak apalah, nanti you tengok. Okay, some of the students say kan? Okay. Apa dia? Dia tak faham lagi. Okay, tak ada masalah Okay, so saya telling something Okay, kalau nak mudah lah. Saya telling something. Okay. Bit ni saya ajar cara nak lukis. Sebenarnya sebab saya kata dalam com ni, signal dia boleh je bagi differential Manchester starting dia macam ni. Starting like this boleh. Tapi tak apa, saya bagi tahu berdasarkan dalam gambar ni. Sebab saya kata com ni very complicated, nanti pening kepala. Okay, nanti sekarang ni apa cara nak lukis? Kosong macam mana? Okay, let's say Manchester encoding. Okay, saya bagi tahu Manchester encoding. Mula-mula dia tulis kalau 0 dia turun tangga, 1 dia naik tangga. Okay, now kita tengok dalam gambar rajah ni macam mana dia lukis. Okay, untuk differential Manchester pula, starting saya bagi tahu you starting dia saja. Nanti you pening. Jangan tengok yang after this nanti you pening. Okay, starting saja you how to draw this thing. Okay, starting dia. Maksudnya kalau beza dia dengan Manchester, dia terbalik. Okay. Yang sini dia 0 naik tangga, 1 turun tangga. At this part, how to set up. Okay, initial. Okay, the rest, bila you dah tahu set up ni macam mana, 0 macam ni, 1 macam ni, the rest no problem. Remember something, if bit 0 will follow, okay, and then bit 0 follow, when mid bit 1, change. Bit 1 change. That's all. Okay, siapa yang tak faham lagi? I give you 1 minute. Okay. So okay lah, nanti saya bagi tutorial mesti ibu jawab ni. Okay, now we go to bipolar. Okay. In bipolar using 3 voltage level. Ni yang paling penting. positive, zero and negative. Ni kena ingat bipolar, we got 3 voltage. Okay, unipolar 1, polar 2 voltage, bipolar 3 voltage level. Okay, bipolar normally we call AMI. Okay, nama dia AMI. Alternately mark inversion. Okay, kadang-kadang tak berbual RZ lah sebab tak tahu saya kadang-kadang normally dalam setengah buku dia tulis AMI aja. Okay, so apa yang you nampak dekat sini? Okay, 0, 0, 1 tak ada masalah, 0. Okay, ni saya nak ajar you. Beza dia dekat sini. Sini dengan sini. Okay, this is the difference. Okay, macam mana, kenapa you tengok kalau dalam kes ni kosong, semua kosong. Okay, how to draw? Bit 0 or bit 0, semua jadi 0. Okay, no problem. Okay, yang beza dekat bit 1 saja. Okay, bit 1 maksud apa? The first one is 1. Okay, meet the another one. Okay, ni 1 bertemu dengan 1 dia ubah. Okay, 1 bertemu dengan 1 dia ubah. Change. Okay, 1 bertemu dengan 1 dia ubah. 0 no problem. Okay, faham tak yang ni? Tak faham, you can asking me now. Sebab when you see the something like the theory one, something like in bila you tengok dalam tulisan, you memang tak faham. You kena faham logical thinking. Saja semasa dulu semua macam tu, logical thinking, then okay. Okay? Faham tak cara dia? 1, alternately positive and negative, 0, low level. Maksudnya kalau 0, semua berbual 0. Clear? Senang je ni, okay je, jangan risau. Okay, now. Application of line coding. Okay. For long distance transmission. Bandwidth input efficiency is important. Bipolar coding is used. Okay, ini jarak jauh lah. Okay, bipolar. Ingat for long distance, bipolar. Okay. And then, for short distance, like local area network. Local area network like this, settling something, sometime, student tak faham tau, local area network guna kat mana. Okay, settling something. Okay. Sometimes, ni berlaku jarang lah, tapi student tak perasan. Sometimes student tak perasan. You login dalam you punya campus, tapi you tak perasan what happen. Okay, sometimes dia jadi macam ni. Okay. Case dia, student register to UMP Wi-Fi. For example, tahu kan UMP Wi-Fi yang you klik mana? Yang you klik pernah tak you tengok wireless tapi itu nama dia wireless LAN. Okay. Student yang you punya Wi-Fi tu, pernah tengok tak yang dekat UMP kan? Kat UMP dah ada kata Wi-Fi for staff, Wi-Fi for student. Pernah jumpa tak benda tu? Pernah tak? Takkan tak pernah jumpa? Wireless kan you nak register kan bila you kat UMP kan in your classroom, you nak masuk dekat, you nak dapat data percuma kan you tekan, you open you punya Wi-Fi, lepas tu you terus klik. You klik dekat, you register dekat UMP punya. Kan dia kan tulis Wi-Fi for staff, Wi-Fi for student. You klik yang Wi-Fi student. Pernah kan? Okay, pernah Fatih Amira cakap pernah. Okay, yang tu nama dia local area network tapi wireless. Wireless LAN. LAN tu wireless local area network. Okay, benda ni normally jadi macam ni. Okay, sometimes internet tak ada tau. You tak tahu sebenarnya bila register dekat Wi-Fi internet, Wi-Fi internet UMP, bila kadang-kadang internet down. Tapi kan bila you type www.ump.edu.my, you boleh terus main internet tu. Tapi bila you type www.google, tak boleh buka. Itu nama kita guna local area network. Jarang jadi sebab you tak perasan kerana you main internet je kan. You tak perasan. Itulah nak tunjukkan adanya local area network. Dan local area network selalu kecil. Macam kat UMP kan, UMP Pekan saja ada local area network. Maksudnya in the campus. Kenapa kita guna local area network? Sometimes bila tak ada internet, UMP still berfungsi. Means saya boleh hantar data, contohnya saya boleh hantar memo dekat Contoh macam ni, saya tunjuk you. Sebab saya kata difficult nak explain. Okay, contoh macam ni. Okay, katalah internet tak ada, right? Okay, saya tunjuk ni. Okay, saya tunjuk wireless, macam mana wireless. Okay, ni contoh, ni saya punya ni lah, e-community. Contoh Okay, saya tunjuk contoh. Okay, let's say lah internet tak ada tau, internet dekat luar tak ada. Tapi kita boleh, contohnya macam let's say tak boleh juga nak message no internet connection, tapi bila dah masuk dalam wireless local area network, boleh message macam ni. Kalau kata saya tulis macam ni kan, boleh still message, even internet tak ada, still boleh message dengan staff-staff yang ada dalam UMP. Kita guna memo system. Okay, memo system ni disambungkan disambungkan menggunakan local area network. Internet tak ada pun still working. Tapi biasa student memang tak nampak. Clear? Itu fungsi local area network. Maksudnya you can communicate similar like internet but in the small range. Tapi tak boleh keluar, you hanya boleh dapat data-data yang dalam UMP saja. Something like this. You boleh tengok result you punya exam, you boleh you boleh tengok kalam, turuning. Kan kalau dalam kampus you mesti you boleh masuk dalam ni. Okay, contohnya lah. Okay. Okay lah, saya cerita lebih-lebih nanti pun tak faham. Okay, it's okay, nanti you tengok sendirilah. One day, bila you masuk dekat wireless local area network UMP, you register, right? Sometimes bila you Google, Google not working lah. Why ? You Google the Star newspaper semua cannot working, tapi when you type www.ump.edu, working lah. Means you are using local area network. Okay. Now, Manchester encoding is used. Itu you kena tahu teknik dia. Kita guna Manchester encoding. Okay, so basically your quiz like this. Okay, I give you the bit stream from the PCM and then you draw polar return 0, null return 0, AMI and so on. So please after this try to do this example. We discuss next class. Okay. Okay. Digital modulation. Okay. This one we go to ASK, FSK, PSK. Okay, similar. This chapter also need you to draw. Okay. Okay, we go. In digital communication, the modulation process corresponds to switching or keying the amplitude, frequency of phase of a sinusoidal carrier wave according to incoming digital data. Okay, you tahu kan before this study, you belajar ni kan? Ni, ini adalah digital data. Digital data. Digital data, after that, you akan pergi pada, lepas ni digital data lah, katalah this one, Manchester. Manchester, contoh Manchester, now proses ni. Digital modulation. Ingat tak? Analog modulation macam mana? You put in modulator kan? Sini pun sama. You kena masukkan dalam digital modulator. Okay? So, dalam digital modulation, kita main proses switching or keying. Ini, nak hantar data tu. Okay? You kena compress macam yang before this, you belajar pasal analog modulator. Combine the carrier with information signal. Okay, itu yang you belajar dalam analog. Now, digital modulation, dia ada juga modulator. Okay, modulator kita tak gunakan combine lagi. Before this, you belajar mixer, right? Mixer you belajar dalam analog. Okay, mixer, what is the function of mixer? Combine. Mixer or act as a analog modulator. Ini dalam AM dulu and FM. Okay. Now, bila digital, kita tak ada lagi mixer. Kita panggil switching or keying. Sama je, maksudnya nak combine, bila jumpa Manchester line coding ni, kita nak hantar dia. Okay, nak hantar that signal. So, nak hantar, kita ada 3 teknik. Okay. Amplitude shift keying, frequency shift keying and phase shift keying. Okay. Now, ni kena tahu ni, bit rate. What is the bit rate? Number of bit transmitted per second. Okay. You pernah dengar tak? This one. 100 megabit per second. Bila you tengok dekat line internet you. Okay. Pernah tak nampak? Kadang-kadang tulis 50 megabit per second. Pernah tak jumpa? Pernah jumpa tak dekat internet? You Google dia punya data speed berapa? Oh my god, student saya tak ada main internet ke?
Pernah sir, pernah.
Pernah kan? Dia tak pernah main internet ke? Saya takutlah. Okay. Contoh sebagi. So risaulah sebab student saya kan, ni yang saya risau. Right now, right, student you pandai guna teknologi but you don't know the fundamental. That's why engineer, you must know the fundamental. Okay, this is the difference between us and normal people. Okay, engineer, you know what happened. Macam ni kan, you tahu, you know the internet. Tapi kadang-kadang cakap, internet ni slow lah. Apa lah internet. Lepas tu you check dekat apa? You check dekat ni. Sekejap you check dekat sini contoh Sekejap saya nak tunjuk kat mana ni. Okay ni, kadang-kadang kan you pun pergi dekat check speed. Okay, I nak check speed lah. Okay, you pun type kat sini. Contoh lah, you kata kenapa internet hari ni slow You pun check yang ni, contoh macam seseguna ni. Fast.com. Kenapa internet hari ni slow? Fast.com contoh. Contoh, ni saya gunalah fast.com. Okay, kenapa hari ni internet sangat slow? Saya pun test. Okay, I want to test the speed lah. Okay, see nampak tak dia ubah nilai dia. Kejap 14 megabit per second, kejap 12 megabit per second. Ni dia tengah run. Okay, dia tengah ping, send and receive. Oh my god, 14 megabit per second. Hari ni lah contohnya kan, dia dapat 14 megabit per second. Oh, you pandai. Allah, what? Oh, now I know lah internet speed 14 megabit per second patutlah slow kalau dekat Unify, tengok kat Unify. You pandai sebut, sebab tu saya kata saya tak suka student zaman sekarang, you pandai sebut you are Gen Y tapi you don't have knowledge in this term. Okay, you tak faham. You hanya pandai sebut je but you don't know what happened. Ini yang saya nak ajar you. Dalam kelas ni, di subjek PCOM memang subjek yang updated. Maksudnya related with the normal environment. Okay, ni contoh you beli kan. You pergi kat sini. Oh, internet right. Okay, nak pilih yang mana? Selalu student zaman sekarang. Okay, saya tunjuk something Okay, saya nak ambil wifi. Kejap internet pun slow. Okay, saya nak ambil for my home fiber broadband. Now saya teach you, that's why saya kata important tau when you come take this subject. Subjek lain tak ajar related with this thing. Saya bagi tahu. That's why you must take PCOM. Okay now. Nampak tak? Okay now. Apa yang nampak dekat sini? Nampak tak megabit per second Mbps? Nampak tak? Nampak tak? 100 megabit per second. Okay, mana yang you nak? You nak 100 megabit per second ke 30 megabit per second? Mana yang you nak? Kalau you jadi nak subscribe Unify you nak ambil package mana? Mana yang you nak? You nak 100 megabit per second ke 30 megabit per second? Mana kalau yang dalam screen you nak ambil yang mana?
Yang 100.
100? 100 megabit per second. Kenapa? Why you need 100?
Lagi
laju lah.
Lagi laju right. Sebab tu saya kata kalau tapi tengok 100 megabit per second apa jadi? Harga dia mahal. Betul tak? 129. Betul tak? Kalau 30 megabit per second harga dia murah 89. Faham tak? Nampak tak? Sebab tu saya kata, okay now, go to the subject. Ni saya nak bagi tahu. Sebab tu, saya nak you kejutan elektrik, right? You kejutan elektrik, you kena pandai in term of after this, please. Don't say, oh, why lah speed Okay. Now kembali balik internet problem. Okay, tak apa. Okay now. Understand this thing megabit per second. Okay, kejap. Saya share balik. Sekejap saya share balik. Tak boleh.